are quite a few school groups that are watching. So my name is Mesa Salaita, and I am one of the co-founders and co-directors of Science ATL, which is the organization that produces the Atlanta Science Festival. I started the festival 9 years ago, and I did not imagine how big and great it would be today. And we are delighted to have the German consulate working with us as they have the past few years to produce an event. And it's just so great. I love having this, like, the way science is so international, and everybody from across the world can participate. And in this format, which I didn't think was great 2 years ago when we were all forced into it, has offered us oddly wonderful things, like being able to have classrooms tune in during the day to listen, and to be able to connect up with Germany to have a presenter direct from the other side of the world. So we are delighted to welcome the German consulate, and I'm going to pass it over to them to carry on the show. Thanks so much, everybody.
Yeah, thank you very much, and good morning to everybody. My name is Melanie Moltmann. I'm the German Consul General here in Atlanta. And yeah, it's been fun and a real pleasure to work together with the Atlanta Science Festival. And so we decided to join them this year as well. And I would like to present to you, well, a marvelous guy and somebody who says that, well, he doesn't like science, but he loves science. And this is Dr. Joachim Hecker, who originally worked as an engineer and as a journalist, but then he discovered his love for explaining and showing science to children. So he was writing books, he had started a radio show, and then he started a show, like you will see today. So, and if you have ever wondered whether pickles, for example, could get tickled by high voltage, or what you can see with infrared eyes, or why suction cups won't work on the moon, then you have a chance to find answers to these funny and crazy questions now. And yeah, I don't want to hold you, but he should be in charge. Just one comment. If you have questions, please do ask them. Feel free to post your questions in the chat, and we will try to answer as many as possible after the end of the show. So thank you very much. Have a lot of fun, and I will hand over to Dr. Joachim Hecker.
Thank you so much for the introduction, Maisa and Melanie, and it's a pleasure to be here. And we will have, for 3/4 of an hour, we will have science, and then we have a little bit of Q&A, and heartily welcome from my person. And we will start with an animal experiment. It deals with these 2 frogs. These frogs are made from plastic, and a very special plastic. It is called styrofoam. Yeah, we know it very well. And so they don't live, and so we are allowed to make experiments with them. These are twins, and they are called Love and Hate. And Love I will keep beside me, and Hate I will put up over there. And please come with me. So there's a pot here, and I will place Hate inside. And as you know, frogs, they love water, and so I will make comfortable for Hate and give some water to him. They live on lakes and creeks, and they do love humidity, and so it becomes some water. Okay. And now please have a look at this frog, and yet I will close the pot. And as you can see, it is a steam pot, and it becomes very, very hot here inside, and there's a lot of pressure because of the steam. And now I introduce you to my kitchen. Please come with me into my kitchen. And we will go through the room into the corridor. There's a fabulous light show, as you can see. And now we will enter the kitchen. And there's the oven. I will place the pot there. And you can see We are in Central Europe, we are 5 hours in advance, so it is nearly 1 p.m. now at my home. Okay, there's a lot of cups for a lot of coffee, and this is the sink, and I can make hot water for tea and coffee. The coffee mill, very important for adults. Here I make warm water, and the central heating is over here. This is my microwave. It is a very important device, I can tell you. And the coffee machine, the radio. And this is a view outside from my kitchen window. And it is a very sunny day. It is a very, very beautiful day. Okay, let's go back to the oven. Now I will switch on and choose temperature and adjust to 180 degrees Celsius. This is very, very hot, 100 degrees Celsius. And it takes about half an hour, and we will use the time to make some other experiments in the meantime. Come back with me in my laboratory, and there I am again. Okay, and we can have some other experiments now. And this, for example, is a paper box, and you can see it's a bit strange because one side is longer than the others, and one corner is higher than the others. It's a very weird box, and there's a hole in there too. And it's a very special box. This box is very, very magic, and I will show you now. Therefore, I need two very important friends. These are Kinder eggs. I don't like Kinder eggs. I love Kinder eggs. Oh, yes. And I will place them inside. So, one here and the other one here. And then we will have a look inside. You remember? They had the same size, but now we will look inside this box. So come with me. Have a look inside through the hole, and then we can see inside, and now they have a different size. The left egg is bigger than the right one. Is it magic? Oh no, it is science. It is very magic science. Have a look from the upside, and then you can see, one egg is closer to the pinhole, than the other one. So, of course, the left egg seems to be bigger. But there's another effect too. The left corner is smaller, so the egg seems to be bigger in relation to the corner, and the right corner is bigger, so the egg seems to be smaller compared with the corner. So there are two effects added together. One egg is closer to the peephole than the other, and one egg is standing in the small corner and the other egg in the big corner. And this makes, if you look from this point and only from this point inside, it seems to be an ordinary room, but it makes things bigger and smaller. It is really magic. This is the famous Ames room. It is named after an US-American psychologist called Mr. Ames, and he developed this room 80 years ago, and it is very popular even today, and you can visit in science centers and you can go inside there. For example, here, this is an empty Ames room, and if you go in and you place yourself in the right corner, you are bigger than the person in the other corner. You can even watch the Ames room on TV and have a look here.
This is quite something. You won't quite believe this. Throw us the ball. We have the ball.
We're in a room that was designed by Professor Adelbert Ames, the guy who made that window that cut you in halves.
That cut me in half. I
Right.
remember it well.
Now, this room has been designed so that you can't tell how far back from the camera or from your eyes something is. So, for example, if I go over to this corner and you stay in that corner, right back in that corner there, have a look at this.
That's incredible.
Isn't that amazing? Yeah. And if we swap positions...
Deplay.
And if we swap positions, you come this side, I shrink, and Darryl becomes a giant. There we are.
No worries.
Okay.
Chuck us the ball.
There you go.
No worries. There you go.
Watch the ball. And you see the ball changing size, right? It's small here,
This is
twice the size.
This is absolutely incredible.
Right, if we change sizes again...
If you had one of these at home, it would be absolutely fabulous. So I go back into the corner.
And the reason it works is because we assume in our mind that everything is square and rectangular.
Yes.
Most houses and rooms are. This one is not. Nothing is square and rectangular.
Yeah.
In fact, if you look at the
You
picture
go down
rail
the picture
here,
rail, yeah.
I'll show you. It's about metre and a half on this side. Watch my hand. There it is. Look at that. Over in this corner, it's about 3 metres high. There are 304 tiles on the floor. You assume they're all square. None of them is. And in fact, if you get a wide look at the whole room, you'll see that in fact it's sloping up like that.
We've got
it's
that
such a
slope there.
powerful illusion
Right.
that it's being used in movies to make things grow and shrink,
Well,
to make
for
streets
instance,
look longer.
If you could build one...
It's so wonderful, the Ames room, and I don't like it. I love it. But there's one thing concerning the Ames room, it is not dangerous at all. But now it's becoming very, very dangerous because we will make experiments with high voltage. In Europe, in Germany, we have 240 volts. In the United States, you have 110. So this is really hard stuff inside there. And never ever touch here inside. Why? Because we as human beings, we do conduct electricity very, very well. I will show you. This is a so-called sensor stick, and it has 2 contacts on the left and on the right side, and I will connect them with my body, and then there's a current flowing into my right arm through my body and out of my left arm. Yeah. By the way, I was kidding. It is not dangerous at all, but it demonstrates that we as human beings do conduct electricity very, very well. But why do we conduct electricity? It is very simple, because we consist out of water for about 50%. That's the reason why electricity is so dangerous to us. And now, ladies and gentlemen, we will test something. Here I have pickles. I don't like pickles. I love pickles. I will take one out of the pot. So, 1 pickle. And, no. We will have an experiment with it. Let's have a look if this pickle is conducting electricity. It does conduct electricity because it consists out of water for 50%, as we as human beings too. And now I will connect this pickle to high voltage. And this is very, very dangerous. Never do it yourself. It is made for mad scientists like me, but you can attend. Have a look now. So these are two bottles of water. And we will open them. And we will put some frogs in it. So we will connect it with cables. So, and here, and now I will place the gherkin, the pickle on top. So, okay, and now I will connect it with a plug. So I will connect and switch on and have a look now. Oh, OMG. Oh, whoa, 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 whoa. Jesus. Whoa. You can see the pickle burning. And let's switch off now, disconnect, and that's the result. I will take the pickle now. Oh, it is very, very hot. Ooh, yeah. And it looks like charcoal. And to be honest, it tastes like charcoal. It is very, very insane. Oh, so much smoke. Yeah. And this is why electricity is so dangerous to us, because this can happen to us too. So be very, very careful, please, with electricity and electric current. Okay, put it away. This is my most dangerous experiment. And now we make a very harmless experiment. It deals with this balloon and, oh gosh, I can't inflate the balloon because I knotted it before. That's a pity. Can you inflate a knotted balloon? We will try it. And I will invite you another time into my kitchen. And please come with me into my kitchen and we will walk together in this very special room. Okay. Oh, very steamy here. There is the pot with the frog inside. But we will go to the microwave. And I will place the balloon inside the microwave, close the door, choose high step and 10 minutes. And now we will start the experiment. And have a look at the balloon. It is spinning around inside. But soon the balloon becomes bigger. Yeah, really, really big, as you can see. And I will take it out. And this is the balloon of the microwave. It becomes really big. So, come back into my studio. So, and it seems to be magic too. This balloon was inflated automatically inside the microwave. Is it magic? No, it is pure science. Because inside of this balloon, there was 1 spoonful of water. And what happens in the microwave? The water is heated, the water starts boiling, and it changes into steam. And steam needs much more space than liquid water. And therefore, it is inflating. The thing is, if the water cools down, it turns back into liquid water and the balloon shrinks. Yeah? And you can do it yourself with your parents beside you or some other adults, and then you can try it yourself, but never ever, please, take more than 1 spoonful of water. Otherwise, the microwave could be defect. Yeah, could be can explode because it is pressed out from the inside. Okay, wonderful experiment with microwaves. We can't see microwaves. We can't feel them. We can't hear them. We can't smell them, taste them, because we have no sense for microwaves. And microwaves are part of the family of electromagnetic waves. This is microwaves. We can see some electromagnetic waves. This is the so-called visible light. We can see these are the colors of visible light. And on the left side, there is the so-called infrared wavelength. It's a very special wavelength we can't see, but with help of technique, we can enhance our senses. And so we will do now. And inside of this tiny black box, there is a very special camera. It is an infrared camera. And I will connect this camera with my smartphone. Wait 10 minutes, no, much faster. And yet we can watch with infrared eyes. And what we can see, I will show you soon. And this is me, seen with infrared eyes. And you can see my nose is a bit cold because I'm a bit excited being live in Atlanta this morning. And you can see my glasses seem to be cold, but glass is blocking infrared wavelength, so the glass seems to be cold. Yeah? And now I will press my hand on the table. I will press my hand on the table and count to 10. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Take my hand away, and then you can see my fingerprints. Because the heat is stored inside of the table has a sort of memory, and you can see the heat of my hand for several minutes. That is really magic. Infrared wavelength is really magic because you can see much, much more. For example, now I will take an ordinary sheet of paper. So put this away. I take a sheet of paper and I take a pencil and I place it here and I will draw with the pencil on the paper. So nothing special, very ordinary, but how does it look with infrared wavelength? Have a look here. And you can see there's heat. Because there's friction between the pencil and the paper, and friction creates heat. And this you can see. Okay, how to erase it? Very simple with an eraser, of course, but what can you see then? Have a look. That is an eraser. And it becomes hot too. Because there's also friction, and friction creates heat. Very, very simple. But magic. Wonderful. So, that's me again, seen with infrared wavelength. And this is a balloon. And I will stretch the balloon. It's nothing special, but how does it look with infrared eyes? Have a look. This is the balloon. I will stretch it and it becomes hot. Because I put energy, work into the balloon and it is turned into heat immediately. So the balloon is becoming hot. You can feel it if you stretch it and put it on your mouth because it is very sensitive up there. I will inflate the balloon. Close it. And look at my face. Can you see my face? Of course you can see it. Can you see my face now? Of course you can't see my face because the balloon is between us. And now have a look here. With infrared eyes, you can see through the balloon because for infrared wavelength, the balloon does not exist. It is magic. Infrared wavelength is able to pass the balloon. Fantastic. I don't like infrared. I love infrared. Yeah? And because infrared wavelength can pass things, astronomers, they don't like, they love infrared. Because with infrared wavelength, you can see till the end of the universe. Through dust clouds and gas nebulas, it's absolutely no problem. And what can you see then? Have a look. This is very famous, the so-called pylons of creation, very famous in space. And these pylons are seen with visible light. How do they look with infrared? This way. And you can see many more stars, thousands or million more stars. It's amazing. This is the Lagoon Nebula, left side with visible light and on the right side with infrared. And again, you can see many more stars. This is the famous Helix Nebula. It looks like a dragon eye. And on the left side in visible light and on the right side with infrared. Let's go back to Earth, ladies and gentlemen. These are my eggs from tomorrow. Yeah, my boiled eggs from today, from this morning. And you can see they have a different color. The one egg is brown and the other egg is white. How do they look with infrared? There's absolutely no difference. And I guess if we people would watch more with infrared eyes, we would have less problems on this beautiful Earth because it is absolutely unimportant which color people have. That's fantastic. It doesn't matter with infrared if people are blue, green, red or yellow. Fantastic. During COVID time, I was much time inside and I would like to visit the zoo. And I would like to take you with me into the zoo. There are many animals, small ones and big ones, and I like the elephants. And let's go to the elephants. And here you can see an elephant with infrared eyes. And you can see the elephant has blue ears because the ears are very cold because he's cooling down his body temperature with the ears. And you can see something else. This here is very freshly made for us. So this is the rhino, and you can see it has cold ears too. And when have you attended a concert last time? It is 2 years ago. I was at a concert, a classical one, and I took my infrared camera with me. And I asked one of the musicians if I'm allowed to make an infrared video of him. And he said yes, it was a violinist. And what did I see? I filmed it and brought it for you. And then you can see the strings are becoming really hot because playing the violin is really hard work and there is a lot of friction and friction creates heat. Yeah. Oh, let's have a walk outside. It's very beautiful as you have seen in Germany at the moment. We have sunshine and I would like to go into the park. And this is a typical park scene. And have a look at the white dog, please. And even with infrared eyes, you can see, stay cool, it wasn't me, go 2 steps ahead and stay. So, this is infrared, and therefore I don't like infrared. I love infrared. It is really fantastic. I love cereals. I eat a lot of cereals, and this is the empty cup of my cereals this morning. And what are people doing with an empty cup? Most people throw it away because it is waste, yeah? But such an empty plastic cup is worth to keep it because it shows us something very strange. And therefore, I write on the name of the most beautiful city worldwide, and this is, of course, Washington, D.C. Oh no, it's Atlanta, of course, yeah? And on the other side, I will draw the picture of an animal with 2 eyes. So, you can think about which animal could it be? This is a cat. And now we need a very special device. And it's here. This looks like a gun. It is a gun. It is a so-called hot air gun, or as I say, it is a very, very hot air gun. 500 degrees Celsius hot air is coming out of here. And now I will switch on this gun and have a look inside. It's glowing inside. Yeah, it's glowing. Oh. And now I take the cup and I say, auf die Plätze, fertig, los. So, go there, over there. And it's becoming really flat. And to finish, I will press it. So, and now, remember before and after. If you look carefully, you can see a little difference. Ha, ha, ha. The cup did not melt, the cup shrinked. It shrinked because this ordinary cup has a so-called shape memory. It can remember its old shape because this cup was once made out of a disc. The disc was heated, sucked down, and then it was ready. But if you heat this cup, it starts to remember its old shape and it moves into the old shape. Because it shrinks and it does not melt, you can see what's on the outside. The Atlanta is a bit more narrow, but a little bit higher. And what happened to the cat? The cat is a frog now, a frog with a beer. Yeah. So this happened to the cup. That's shape memory. You can try it yourself, much better in an oven at about 120 degrees Celsius. And it works with cups made out of PS. That's the nickname of polystyrene. This is a very good material to try the shape memory. And you can use shape memory to save lives, because if your grandpa has a heart attack, he becomes a stent, a very special device, into his heart. It's made out of metal and it vibrates because of the body temperature, and then the blood can flow again to the body. It's really, really wonderful. Shape memory can save human life. Wonderful. Okay. Then I would like to show a very simple experiment. This is the egg of this morning. And is it able to place an egg on the table without the egg cup? Let's try it, if it works. It is very difficult. Okay, it does not work, but with help of a little bit salt, we can try it again. Put some salt on the table, so, yeah, and place the egg inside the salt again. So, and then you can see, the egg stands there. Yeah, there is the egg standing. And think about how many grains of salt do you need to stand up this egg upright? How many grains do you need? So, in that last experiment, we will go into the kitchen and get the steam pot back into my laboratory. Come with me, please. Okay. Oh, I can hear it. Oh, very steamy inside. Oh. Oh. Very, very hot. And first, I will get away the pressure and I say, auf die Plätze, fertig, los. Oh, very much pressure. And now we will open this pot, and the first people worldwide having a look inside are the curious people of the city of Atlanta. Okay, come with me, please. So I will open, and voila, that's hate. I will put it out, and to compare it, have a look. This is love, and this is hate, yeah? And hate has become very, very small. What happened into the steam pot? It is very hot inside, more than 100 degrees Celsius, so styrofoam becomes soft. Inside the steam pot, there's a lot of pressure, and the pressure squeezes the air out of the styrofoam. And that's the amount of plastic inside of this styrofoam frog. It is so many plastic. The rest is nothing else than air. And you can see also that love should be much bigger than hate in daily life. Very, very important. Okay, and now we have time for some questions, and Constanze will manage the Q&A session, please.
Yes, thank you very much, Joe, for another wonderful show. I've watched it a few times, but it's always exciting again. You know, especially your final message, one that we need to heed in these days in particular. So I've looked at the chat and there were a few questions. The first one is that a teacher would like to do the balloon experiment, but they don't have a microwave. So is there something else they can do to perform the balloon experiment without the microwave?
No, it's just made especially for the microwave, because the microwaves itself, they can go into the balloon and heat the water. It does not work else. It's the only way to inflate the balloon, the knotted balloon. It's the only way to inflate it with microwaves. Mm-hmm.
Okay, so maybe there's a microwave in the school kitchen. So, you know,
yeah, I think so.
Field trip to the school kitchen.
Yeah, good idea.
We had lots of questions about the infrared. So the first one is, how does your body get so warm?
The thing is, because we have we eat something and we turn the food into heat, into energy. We are heated from the inside, and you could see our head is very hot, because half of our body heat we do lose via our head. Yeah, so our head is like we are like a light bulb. Seen with infrared lights or wavelengths, we do light like a bulb. Yeah, that's the heat of our body.
Thank you very much for that. The next question is, how does infrared work if we don't know what it looks like?
What you have seen on screen at the elephant, for example, you can see these are so-called false colors, because infrared itself has no color, because the colors are used for the visible light. Yeah, for this there are all colors used, but the colors do represent different temperatures. So blue is cold, and green is cool, and red is warm, and yellow is hot. So the different colors do represent different temperatures.
Great. So the next question is, can you explain a little more how the pencil shows heat on the infrared camera? So why is there you know, the red mark when you scratch the pencil across the paper?
Yeah, because the top of the pencil is very, very small. Yeah, it's like it's as big as a needle, and so there is a lot because of the pressure you write with. There's a lot of friction, and this friction is turned into heat. So really, an ordinary pencil or a pen is becoming hot, but just at the top, of course.
All right, and another question is, how did people discover infrared?
It was one famous person in history. He's called Fraunhofer. He discovered infrared because he used a triangle, a glass triangle, where you can split the sunlight into the different colors, into the rainbow colors, and he detected that behind the red, therefore it is called infrared, behind the red, there he couldn't see anything, but a thermometer detected heat there. And so he discovered that there is something you can't see, but you can't measure with a thermometer.
Great, thank you for that. So lots of questions about the frog. Does the frog still weigh the same?
Pardon?
Does the frog still weigh the same? Is the weight of the frog still the same after it has been pressurized?
Yeah, mainly yes, but because there is less air inside, it's a bit lighter than this one. This is it's more heavy than the small one because there's more air in it, and air has a weight too. Very good question. Great. Mm-hmm.
And can hate be returned to its normal size?
You can't do it because it's a very special process to create styrofoam. You need this little plastic balls, and they are heated, and then there's a gas coming out of them, and it creates the foam. So you can't turn this frog into its original size again. But compared with a cup, by the way, it's the same material, styrofoam, and the plastic cup, it is polystyrene. It's the same as material. This disc you can turn into a cup again. Yeah. So this is just one way, but with a cup you can do it back and forward. Yeah, as you like.
So is the smaller frog any harder than the other one? So.
A very good question. It is very, very solid. I can tell you, it is hard like a brick.
And let's see, how did the frog in the pot keep its shape when it lost the air from the styrofoam?
Great. These are very, very tough questions, because you can learn that inside the steam pot, the pressure is the same from all sides, from down, from top, and from left, from right, from the front and from beside. The pressure is always the same, so the frog is shrink proportionally. Yeah, that's very important. It's the law of Pascal, that the pressure is the same from all sides.
All right, going to my favorite experiment, and you know which one it is, the pickle. Was the pickle on fire or lighting up?
Good question. It was not on fire, it was lighting, because there was current flowing through the pickle, and the current, there is electrical energy, and this electrical energy was transformed into heat, yeah, therefore you could see the smoke, and into light. Yeah, a part of this electrical energy was transformed into light, and you could see the pickle glowing, therefore. So it's a very complex process happening inside the pickle while conducting electricity. You can create it simple, this experiment, but it is very tough experiment. You need a lot of background to explain it, and scientists, they do not understand it completely. For example, they do not understand why one side is glowing and the other not. Yeah, there's always one side glowing. Yeah, that's a very strange phenomena.
The mysteries of science, you know, still something left to be discovered. That's always good.
Yeah. Mm-hmm.
All right, back to infrared. How do animals that can see infrared decipher how hot something is?
Some animals, like some snakes, they can see infrared. So they can see, as predators, they can see and other animals they want to eat. And there are, was heißt ein Jäger?
Hunter.
Jäger. Yeah, hunters, they use infrared cameras too. If they are alone in the dark in the forest, they can see, with help of an infrared camera, they can see the pigs and the deers and so on very clearly. Mm-hmm. So some animals use it, and many hunters use it too.
That's great. So a question with recycling and environmentally consciousness in mind, can all plastic retain its shape and potentially be reused?
That's a question. It is, you can melt the plastic and create new one of it, but it is much more efficient to use the original shape, to clean it and to use it again. But mostly plastic is shredded and then formed into new plastic, but the old shape is not often used again. That's a pity.
There are a couple more questions about the pickle. Is the pickle edible after the experiment? And could you use electricity that way to cook vegetables?
Great. You can eat it, but you must not eat it. It really tastes like charcoal. I eat it once and that's it.
Why is the pickle wider at the end?
Because it was really it's like it's cut from the fork, yeah, from the glowing fork. It is cut away. Yeah, it is. Yeah. You don't use electricity to cut. You use electricity for operating people, because the advantage of electricity, if you cut with an electric knife, the advantage is that the wound is closed immediately. So you cut and close the wound at once. That's fantastic. For cutting things, for cutting vegetables, and so you use often lasers. For example, to cut cakes, you can use lasers to get the different slices.
All right. If humans are made from so much water, why are we so solid?
Good idea. Because we do contain the water in a very special way. The water is captured inside our body in a sort of hydrogel, of a biological hydrogel. That's a gel which keeps the water in a slimy way, so it does not leave our body. So we capture the water in our body.
Great. I think those were all the questions I could see in the chat. There were a couple of requests to see certain videos again. I can let you all know that the whole show will be posted on the Atlanta Science Festival website here within a week or so. So you all are able to rewatch the entire show and see your favorite videos. And we all know which one that would be. Again, a couple final announcements. If the teachers would please do us a favor and post in the chat how many people are students were watching with you. For everybody else who is watching this on their own, I'm posting a survey in the chat that the Atlanta Science Festival would like you to answer. Oh, wow, lots of students. Awesome. We had lots of people watching, Joe.
Great.
Lots of signs to go around. Finally, I would like to thank Dr. Joe Hecker, as always, for...
Just short, Constance, how many grains do you need to stand up the egg upright?
Oh, okay.
The last question. We do need just 3 grains. Yeah.
All right.
And you need 3 grains to stand up for table or for chairs too. And in the whole universe, you won't find any chair or table with 3 legs which is shaking. Tables and chairs, they shake with 4 legs and more, but never ever with 3 legs. That's very important.
Great. I mean, there had to be a great conclusion. Thank you so much, Joe. Thank you so much, Maisa Salaida from the Atlanta Science Festival, for helping us organize this wonderful event. Thank you to everyone watching. I hope we could bring science a little bit closer for you, and you all had some fun with Dr. Joe's crazy experiments. Thank you, and we'll see you soon at another event.
Goodbye.